Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Battery Show webinar, the starting point for robotic automation, a beginner's tour, sponsored by Epson America, Incorporated, and broadcast by UBM. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in our Q&A session that takes place at the end of our presentation. Please note that we'll try to get to as many questions as we can at the end of our webinar today, but if we're not able to get to your question today, someone will get back to you after the program is over. Also, the slides will advance automatically throughout the event. You'll be able to see our presenter within the media player. You may also download a copy of the slides via the resources widget. And towards the end of our webinar, we'll ask you to complete our survey found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And lastly, if you're experiencing any technical problems, please click on the Help widget found at the bottom of your screen or type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation, the starting point for robot automation, a beginner's tour. Discussing today's topic is Rick Brookshire, Group Product Manager and Global Account Manager at Epson Robots. Rick has worked in the robot industry for over 33 years, managing various product development, marketing, applications engineering, product management, and technical support teams. As Director of Product Development and Engineering at Seiko Instruments, Rick's teams helped create the first PC-based robot controllers, integrated robot vision solutions, and the core robot development software for Epson Robots, now known as Epson RC+, which is used today in thousands of factories worldwide. After coming to Epson, Rick became part of the Epson Global Development Management team that creates all robot-related products for Epson Robots. Rick has a BS in Computer Science and Marketing from Clemson University. It's with great pleasure I now turn this special session over to Rick to begin. Rick, take it away.
Thank you, Chris. Really appreciate it. And everyone on the line, really appreciate you taking time today to spend with us. We know everyone's busy these days, so thanks so much for the time. We're going to talk today about and for people that have not done robot automation but are thinking about implementing robots into your facility. And we're going to go over some of the things that you need to be thinking about prior to doing that, things that you would want to share with a robot vendor or a systems integrator when you go to do your first robot applications. So it kind of gives you an idea or a heads up for things that you need to know prior to going and starting asking questions of the robot vendors. So let's kind of get started. First slide I want to look at is just the robot world today and what's going on today as compared to kind of in the past. Robots today are running at speeds that are even 3 times faster or more than when I first started some 30-some years ago. Back then, we had our best robots could place to precision like 30 microns, and now we've got applications out there where we're making placements to better than 10 microns with some of our robots. Cycle times in the past, if we could get 5-second cycles, everybody was thrilled. We're now working at high-speed cycle times of below 1 second. Robots are being used in all different kinds of industries, as most of you probably know, from automotive to industrial, medical world, consumer products. Our Epson robots are being used to make everything from sunglasses, contact lenses, hard drives, I'm looking around at things, pens, could be mouse for your computer, cell phones, all kinds of different kinds of products. And generally from the Epson side, what we say is if it can fit in your hands and needs to be assembled, usually our robots are used or can be used for building those products. So there's all kinds of different applications that robots can be used for, and we're surprised every day, every year on some of the new applications that we look at. For example, decorating cakes, which was not something that we would have thought about, or putting gold plating on belts for a guy in Texas, and some things like that, along with the typical applications which are, high precision assembly and those kinds of things. So in general, robots have been used for a wide variety of different industries and a wide variety of different applications. So For those of you that are here today, the reason that you would be here is because you really have two questions in mind. Number one, you've decided that you do have a need to automate, and then number two, maybe not real sure how to get started or just want to get some pointers. And hopefully there's at least one or two things in this presentation that maybe either you didn't know or maybe that you hadn't thought about in some time, and it spurs some thoughts and so on to make sure that you do the right steps for getting started. So let's go through what we're going to cover today. There's really 5 key focus areas that we're going to hone in on during the presentation today. And these are all things that you'll want to think about prior to talking to the robot vendors and or systems integrators that would typically do your robot work cells. So number one, you really have to have a good handle on why are you going to automate. We're going to go through all these in more detail. Then defining your current process. How do you do it today? What are the steps that you use today? And understanding that really well. Then identifying your requirements. You need to understand what it is that you really need out of the automation. Sometimes you need something much more than the way you're doing things today. We'll take a look at some of that as well. What are the components that you may feel that you're going to need to be able to accomplish this automation? And then finally, who's going to do it? Is it going to be a system integrator? Is it going to be done in-house? Are you going to hire some people in-house to do it? So we're going to go over all these things today. So let's get started on the why automate section. So the very first thing that I generally like to talk to people about is this little piece that you see on the side that says organizational alignment on why to automate is a critical success factor. And what this means is we've seen a lot of cases where customers will come to us and the engineers who are doing the development want to automate because they've got to focus on, they've got to get more volume. But then if you talk to the upper management, they're focused on reducing the cost. And if these folks aren't in alignment, then what happens is that some of the decisions that you have to make during the process end up being very tough ones. They turn into some battles in some cases. So some of these areas you want to look at as to why automate, the first one, and generally the most common one, is cost. Trying to reduce the cost per unit is usually the biggest reason why people come to us for wanting to automate. And then right behind that is that they need to increase the volume. So if there's a big increase in demand, you have a lot of people that are manually building your product today, an increase in volume, especially a rapid increase in volume, may be hard to get the people that you need to be able to build your products. So this is a good reason for automating as well. Then third is quality. So quality is a strong reason. If you can get better yields out of your products, have 99.9999% good products coming out, and you can improve that quality, that's always something that everybody wants to get to. In some cases, though, we've worked with customers where their quality today, maybe they're only getting 80 or 90% yields, which sounds really low, but that happens. And so their focus really is in making sure that they're sending out quality products every time. Another reason to automate would be precision. And that seems a little strange, I'm sure, at first, but as is written here, what if humans really struggle with putting some of these components together? When you start dealing with precision in the range of, say, 25 microns or even 50 microns, that's really hard to start assembling something at that level. Just to give you an idea, a human hair is somewhere between 100 and 200 microns thick. So you can understand that starting to deal with 25 micron placement is very precise and very difficult for humans to do. So a good reason to automate would be that you have some high precision requirements. And then finally is safety. There can be real good reasons to automate just because of safety if humans are put in dangerous environments or dangerous situations. We have in the lab automation world, a lot of times people are dealing with types of, we'll call it diseases or some kinds of other things that could in fact hurt humans. So putting robots and automating that with robots is a very good use of the robots. So the next step you got to do is define your process. And there's really 3 areas that we're going to focus on for defining the process. Number one, and probably the most important, is people. You want to make sure that you have experienced automation resources. Now that doesn't mean that you have to have those resources in-house, but you need to have access to them. So you need to utilize some of the resources in the industry that are available. So a lot of the robot vendors, pretty much all of them, will be happy to help you in understanding your application better. So there's some automation resources, experienced ones, that you can tap in free of charge. And also, of course, systems integrators is another great place to go look at in terms of getting some experienced automation resources. And then hopefully you have some in-house or are hiring some as well. Secondly is technology. And one of the things in terms of defining the process that I always want to make sure that people understand is technology alone is not going to solve everything. Just because you have a great robot doesn't mean that it's then going to do great things. Just because you have the best vision system ever doesn't mean that it's going to solve all your vision issues. So you need the technology and the right people to work that technology. And then finally, you need to define your process well to make sure that everybody understands exactly what it is that you're wanting to do so that you can then do a nice crossover between the people and the technology to then meet your process requirements. So in defining the process, first thing we want to look at is how do you do it today? So how is it that we actually put together these products that we're doing? So, and is that process documented? So one of the questions that I generally ask, I've done this presentation in front of live audiences, and I'll ask everybody to raise their hands. How many people have a document that defines their process of how they do things today? And generally in these sessions that I've done, less than half the people raise their hands. It always ends up being there's a lot of folks that don't have that defined. So if your guy Bob is the only one who understands how to do this process and something happens to him, then that could be real trouble for your company. So one of the things I always mention to people is try to find the time, find some way to get your current process documented so that you have that really well defined. Secondly, can you explain it clearly? Now obviously if you have it documented, you'll be able to do that. But you need to be able to define and explain your current process, because if you're going to automate it, then how are you going to automate something if you can't even explain how you're doing it today? So you really need to be able to clearly explain how you do things today. And you have to think about things like, how do you supply the parts, or what we call part feeding? Okay? Are there some special jigs that you use today, or fixtures, and other things that you maybe have to use in your total process? How are you going to then change those and turn those into automated solutions? Secondly, you want to identify what we call the problem areas. So what I generally like to tell people is find the toughest problem areas in the way you do things today. If you're doing things manually, what's the toughest thing you're trying to solve? And let's see if we can come up with some automated solutions for that really tough problem. That will make the project much more justifiable. Also, what's slowing down your current process? So in other words, if you've got right now, say, a 5-second cycle, and 2 of those seconds are taken up from one little step out of the whole process, well, maybe there's a way to reduce that 2 seconds to a half a second. So you want to define what are the different areas that are slowing down the overall process. Do you have to do a lot of reworks? That's something to think about as well. From the rework perspective, that's directly, of course, related to quality. If you're having to do a lot of reworks, then maybe there's something wrong with your current assembly process or something along those lines. And then the other is product volume. Do you have enough product volume? That certainly would be a problem area in that you want to have more product manufactured on an hourly or weekly basis. So let's take a look at a simple process example. Okay, so imagine if we were building these electric outlets. Everybody knows what these are. You can see a picture of it on the side. And so these are some of the different kinds of things that you would want to be thinking about as you were looking at a process to automate these. So number one, you're going to take a look at, well, what's the variety of these products? How many different ones do I have? Is there are there some of the pieces that could possibly not go together correctly if I'm using parts from product 1 and parts from product 100? They look exactly the same, and if they go together wrong, then we're going to end up making bad parts. So is there the potential to use wrong parts because you have this large variety of products? You also want to think about the large variety of products in terms of how you're going to automate, because maybe you have to do changeover every week or even every day or every month. So that's something you'll want to think about as well. Then deviation of part tolerances. So a lot of times companies will get parts from a third-party company, and they'll just entrust that those parts are being made within the tolerances that they need, or they maybe even don't even discuss about the tolerances, and then when they start trying to assemble them, they find out that the tolerances aren't good enough for being able to assemble those products in the manner in which they want to. So you want to make sure that you verify the part specs from the vendor and also any variances that might be there. And it really depends on the parts. We have some parts that people are machining and making down to micron levels, and others, well, as long as it's within 15 microns, it's fine, or 20 microns or something like that. So you definitely want to take a look at this deviation of part tolerance. Proper part insertion. Okay, so lots of different issues here. It could be a right side up, upside down issue. Are you putting the part in correctly just because of it not being right side up? Is the insertion going in a skewed fashion? For example, when you're screw driving, sometimes with screw driving applications, the screw gets turned a little bit and then it gets stripped and it doesn't go in quite right, and that's because of the skewed insertion. And then also making sure that things are properly seated before you go to the next step. These are all potential problem areas and things that you would want to think about if you were making these particular parts. And then the last area, and it's not really, these aren't the only areas, these are just some examples, but fastening issues. So you want to make sure the parts can align properly to be able to do the fastening. So if you were thinking about these products, and if you were still in the process of designing them, you want to possibly do a design for automation step where you make sure that these parts, when they go to be assembled, will come together very easily versus making it very difficult for them to be able to fasten. So like I mentioned earlier, screw driving issues, snap fit issues, all kinds of different related issues to fastening. So you definitely want to make sure you know what your potential problem areas are, and this will help improve your quality at one, but it'll also help you improve your cycle times. Okay, so what we're going to do here is a quick little poll to find out what kind of processes that you guys are looking to automate. We've got a few different questions that we're going to be putting up here, and you can just click on one of these and hit submit, and then we're going to share the results with everyone and the answers that you can give. So here's the question: what type of process are you looking to automate? And the answers that you're going to see are going to be assembly, or pick and place, or packaging, or material handling. So in our world that we play in with Epson, a lot of assembly and pick and place applications are done by Epson robots, especially our SCARA robots. But we offer SCARA and 6-axis robots and linear modules as well. And so these robots are used for a lot of these different types of applications. In the case of packaging, a lot of times our 6-axis robots are used for the packaging. And then we recently released a product called our Synthis T3 All-in-One, and we'll soon be releasing what's called a Synthis T6 All-in-One. And what this is a less expensive, it's all-in-one because we put the controller inside of the robot arm, but it's a less expensive SCARA robot that is the ultimate slide replacement. So in a lot of cases where people are putting slides into applications, these new T3 SCARA robots are being used instead because they're just easier to put together in the overall application. They work really well. So that was something we released about a year ago, and it's been taken off like wildfire. So that's for a lot of the pick and place. Kind of what I would expect in this particular audience, especially given the show that we'll be going to here, the battery show and so on. I would expect there to be a lot of assembly answers here, and that's kind of what we're seeing. I'm going to go to the next slide and let you see what your answers are. So here's what we saw. Here's what came back. So the majority, overwhelming majority, is looking at doing assembly, some type of assembly application. We can say other is in second place with 25%, but that's a whole lot of different applications, of course. And then pick and place comes in behind that. So this is typical of what we see when we do these polls, but just always like for everybody in the audience to get to see this information as well. Okay, so hopefully you got to see that because I know there's a little bit of a delay. So assembly was at 58%, and then pick and place was at 8%, so big gap there. Let's move on. Okay, next area we want to look at is identifying your requirements. So there's this trade-off. We call it a three-pronged trade-off between speed, precision, and payload. In the perfect world, we would get all the precision we need at the largest payload possible with the fastest speed we could ever possibly get. But that's not reality. In reality, what generally happens is we have to do some kind of trade-off. So sometimes we have to give up a little bit on the payload to get a better precision. Or we have to give up a little bit on the payload maybe to get a little more speed. So there's this balance between these three things, and we want to make sure that we get the right balance for our application. If what's most important to us is cycle time, then we want to make sure that we reduce the payload as best we can with tooling adjustments, all kinds of application adjustments, and so on, so that we can get the absolute fastest speed possible. So the main point of this slide here is to make sure everyone understands there's always a trade-off between these three areas of speed, precision, and payload. So let's take a look from the identify your requirements perspective of cycle time. So one of the things that you'll want to bring to the robot vendor or to the system integrator is understanding what kind of cycle time are you expecting. So how many parts are you, and you don't want to think of it necessarily in a, I need this many parts per minute. Think of it from a broad, big picture perspective. How many parts per month do you need to get put together? And then you can start breaking that down into how many you're going to need per week and per day and per hour and that type of thing. But here's one of the things I generally suggest is work with the robot vendors or the system integrators in defining what this requirement is, because they'll be able to help you in understanding and taking that requirement, for example, 1 million parts per month, and breaking that down into how many robots are you going to need, what kind of cycle time are you going to need from each of these robots, so that we can see how much automation you're going to need to be able to meet that particular requirement. So all the robot vendors are very happy in helping you in that area, because what they're going to do is we're going to take a look at things like, as you see here, things like dwell time for the grippers, tool change time, part transfer time, vision processing time, and all these other factors that add up to the cycle time. It's not just about how long it takes to move from one position to another. Sometimes you'll see from robot vendors a champion cycle time of 0.3 seconds or something like that. But that's not a real-world application cycle time, and you really need to be thinking about that. So one of the things I like to share in here, too, is ways to maximize cycle time. So if that's very important to you, here's a few ways to maximize that. Number one is if cycle time is most critical, you want to select the fastest possible robots for that application. So the reason Epson sells a lot of scare robots is there's a lot of customers out there that just need pure raw speed, fast cycle times for pick-and-place applications, and the scare robots are the champions in that area. If you need super fast robots, make sure a lot of cycles, then you want to make sure that you use the best robot or the fastest robot for that. Secondly is layout. So you want to make sure that you do the right layout so that you have the shortest moves. Obviously, by having smaller moves, you're going to have a faster cycle time. Seems obvious, but sometimes we'll get layouts from customers after they've already started trying to run the applications, and they wonder why they can't hit their cycle times, and it's because they're having to do a lot of really long moves, when if they had just shifted the robot by 45 degrees, moved some things closer, we could have helped them reduce the cycle time significantly. Using multi-headed tooling is another idea. And what that means is being able to go over and pick up, say, 2 parts at a time instead of just one. That will help you save some cycle time as well. Then finally, finding ways to optimize using motion and software optimization techniques. A lot of times what we'll do at Epson is we'll have customers send us their software, or they'll call us up and say, we're working on a cycle right now, and I'm going to give you an example actually that you can see here. We worked with a customer that had a cycle that they wanted to beat 30 seconds for their overall cycle. It was doing a lot of different things, but they were around 38 seconds. So they were really off by quite a bit. And as you can see, what we did was we broke things down into the different pieces of the application and found some of those areas that where we were spending the most time, and found ways to reduce those down through different motion and software optimization techniques, and then we were able to get them down to below 28 seconds. So sometimes just using these techniques are really good for getting your cycle times down. The other thing we'll talk about is precision. So remember, we talked about that triangle: precision, payload, and cycle times. So what kind of precision do you need? We, a lot of times, will ask customers about what precision they need, and they'll say, we need 5 microns. And then as we talk to them a little bit more, we find out that they're placing these 2 different plastic components that were injection molded, and they probably don't need 5 microns at all. They probably need more like 50 microns. But they just don't realize that. And so we want to talk things through to make sure that we're putting realistic requirements. But we certainly have other customers that come in and say, we need 10 or we need 15 microns because they're doing very high precision types of placements. So you want to see what's the tightest fit that you might have for the parts that are in your particular process, but then make sure that you add a buffer to that. So if the tightest fit is a 15 micron tolerance, then you probably want to add a buffer so that you could make sure you're placing to 10 so that 15 will be no problem whatsoever. There's a lot of different tolerances that you want to think about. We have this thing we call tolerance buildup, which it's not just about the robot precision. If a robot has, say, 15 micron repeatability, that's not exactly what the application is then going to be able to do, because you've got other tolerance buildup you have to deal with. So difference in part precision, precision. Difference in the feeding methods. So sometimes we think that the feeder is going to perfectly put that part in position every time, but the feeders aren't perfect either. They can get it close. They might get it within a few microns, but they aren't going to get it to 0 microns perfect position every time in terms of having a perfect pick position. Also tooling. Will the part move, or will the tooling move a little bit? And cabling. This is one of those things that we like to share with people. A lot of times people will have cables that are just too tightly bound around the tooling, and it starts pulling. And that pulling can cause a few microns of tolerance problems. And they just didn't realize that that's what was happening. So we help people with that. And then, of course, the robot precision and the motion of the robot can have a lot to do with the tolerances. There are some ways to improve the precision in the performance of your system. 2 ways are using vision guidance. So what we found at Epson is with our Vision Guide product, we're able to approach the repeatability of our robots for placement when we use vision. Because we're able to, once we've picked up the part, detect what that deviation was from part to part and make sure that we're placing with the correct precision. So vision guidance is one way to improve your precision performance. And another way is to use force guidance. So Epson also has a force guidance product we call Force Guide, and that will allow you to feel your way into placing the component. And we have cases where we take 20 micron robots, which has a repeatability of 20 microns, for example our C4, and we'll now take that robot and place into a 10 micron tolerance area. And the reason we can do that is because of this force guidance feedback and tying that into our real-time servo loop. So these 2 areas, using vision or using force guidance, are certainly ways that you can improve your precision. Payload. So let's take a look at that real quick. Payload is more than just what the part weight is. Very important to understand. You have to think about how much tooling. And most of the time, the tooling actually weighs more than the payload that you're picking up. And in our world, which is generally in the 20 kilogram and below world. So you want to make sure that you're adding up all the different things that are related to what's going to be hanging off the end of the arm. You may have some cabling, you may have the tooling, of course, and other things that you're going to have to deal with, tool changing, and so on. So when you're thinking about payload, think about the parts, the tooling, the peripherals, and all these different things. You also want to think about, a little note that we show here, you also want to think about the tooling offset. So if you have an offset that's too far, one of the problems with that could be that the robot's not going to be able to rotate well enough because of inertia limits. Let's keep going through this. So the other thing is that we want to look at in identifying the requirements is the reach and size of the work area. So when you're looking at the overall work cell, one of the things that Epson does is we'll help you lay that out so that you can get the best optimization for the overall system. So you want to think about things like, what's the longest motion? What's the motion that you're going to be doing the most times? We call it the common motion. That's very important for optimizing the cycle times. The robot mounting, are you going to mount it from the ceiling? Are you going to mount it from the tabletop? How's that going to be done? Different peripherals, that definitely defines how big of a robot you need or how much workspace that you need. If you have a lot of peripherals or a lot of parts that you have to deal with in your work cell, then that may mean that you're going to need a bigger robot. to be able to grab all of those different parts. You want to think about things like pallets and trays and the carriers that are going to come in to the system. Do you have a conveyor system that's going to come in possibly? So you have to make space for that as well. So there's a lot of these different things that you want to think about in terms of reach and area, work cell area, when you're trying to decide what size robot. And again, the robot vendors and the system integrators will be happy to help you in determining what that is. So we're going to do another one of these polls, and it's really just asking what your main requirement is. So in these requirements, is it speed, or is it payload, or is it precision? So we'll give you these three different choices. Hopefully the poll comes up here in just a second. And really what we're looking for is just an idea of what's the most critical thing for your particular application. And they vary. We do have customers that will come in and say that the precision is the most important because without it, then they can't automate. We'll have others that will come in and say, we have to hit a 1-second cycle. If we can't hit that cycle, we can't afford to automate. And then we have others that have very large payloads. And of course, if the robot can't pick up those payloads, then the rest of it doesn't matter as well. So there's a trade-off between the three, but generally we'll find that there's a mix, like I said before, but usually there's one driving factor that's driving your application. And I'm seeing people are putting in their answers now. We're going to move this on in just a second. I'm going to give you a couple more seconds, maybe 5 seconds, to go ahead and submit your answer, and then we'll all see. Very interesting results in this case. So let me move on for the sake of time. So what we'll see in the results here was it was almost even. So if we look closely, we'll see that speed and precision both came in at 36.8%, and payload came in at 26.3%. So really, I think it was a balance between all three of them, which means that each of you that are in this call have different requirements. Some of you focused in different areas, and that's fine. Make sure you know the area that you're focused on that's most important to you, and make sure that your whole team is focused on that. Okay, we're going to move on to area 4. We're almost there. We got 4 and 5. Automation components. So these are some of the things you want to think about before automating. So for example, the parts presentation. How are you going to get the parts to the robot? Are you going to use bowl feeders? Are you going to use flexible feeders, conveyors, or other kinds of things? So you want to think about what types of fixturing you're going to use for that. All of these are commonly used, and there are reasons to use each of them. And that's something you want to go over with the robot vendor or system integrator, and they can help you make good choices there. Are you going to need to use vision or force guidance or force sensing? I mentioned earlier that these can help you in the case of you need more precision. It also can help you when parts are deviating or parts aren't always coming in the same orientation. Maybe the parts are turned a little bit or just off by a little bit in terms of position. So a vision system with vision guidance can really help there. And it's why Epson has an integrated vision guide product to help make it really easy to be able to do vision guided robotic applications. The other thing to think about is end-of-arm tooling. What's the kind of tooling that you're going to need to use? Will you need to use a mechanical gripper, or can you get away with using a simple pneumatic solution? Many times, and I'll even go so far as to say most of the time, people have to make some kind of specialized tooling that works for their parts. And that's an area where if you don't have expertise, you definitely want to reach out and get some expertise there, some help from somebody who knows what they're doing so that you don't go through too many rounds of having to change your tooling. Most applications, I've mentioned here, most applications do require that specialized tooling. Other things to think about is tool changers. Okay, the multi-headed tooling considerations. Do you want to pick up multiple parts? Come down, pick up part 1, then part 2, then go place part 1, place part 2. So these are things you want to think about in terms of your tooling. Other things, factory standards. Are there some standards that are in the factory that you're working in? Things like communication standards. Do you use Ethernet IP as a standard, or EtherCAT, or DeviceNet? Those are some of the more common ones here in the United States and North America, but over in Europe they have others like Profibus and so on. So make sure you're following your communication standards. Are there some component standards that are in your factory? Maybe your factory generally only uses one kind of tray vendor or PLC or other things. You want to make sure that you're following that to reduce your total amount of support that's required for your applications. And then robot base. I bring this in because base rigidity is very critical, especially when you start dealing with high-speed applications. We have had, and I tell a story, I won't go into long detail, but I'll just say this. We've had situations where customers called, the base was moving, and we found out that it was a base that they bought a workbench from Home Depot made out of wood and couldn't understand why it was moving. So that's an extreme case, but I joke about it because it's very important that you make sure that the base has the rigidity you need for your particular application. And you need to think about things like, do you need isolation, okay, for your peripheral equipment? Are you going to be mounting the robots from the ceiling or from the tabletop? If it's from the ceiling, you need more rigidity at the high end. Okay, so all of those things you want to think about, and very important is define your layout before you go purchase a base. Worst thing you could do is buy the base and then start figuring out how you're going to lay things out. All right, last area, manpower. So who's going to build your system? The types of resources that are typically required are mechanical engineers, controls engineers, software engineers, what we call process specialists. And a process specialist may not be an engineer at all, but somebody who understands how you do your application today. That guy is very important because he'll be able to help you make sure you don't miss any steps. And then in the best projects, you also have a project manager that's kind of aligning all these different people together. So are you going to be, assuming you need all those, then are you going to be able to do it internally, or are you going to need external help? So system integrators, there's a lot of good ones in North America that have been doing this for a long time. Very good resource to be able to do your applications, get your applications done all the way up to turnkey level. Or we have a lot of customers we work with that have outstanding in-house automation groups. If you're one of those, consider yourself very fortunate because amazing things come out of some of those groups. And then there's those that are newbies. So we call them newbies because they haven't done automation before. Hopefully there's a lot of you on this line and learning. And we've had a lot of new folks do amazing things with our robots, especially the T-Series that I mentioned earlier, our low-end, low-cost scare robots for more simple applications. And we're happy to help those newbies get up to speed on how to do automation, things to look out for, and so on. But one of the most critical, important things, no matter how much time you have in this industry, how much experience you have, don't try to do it all just by yourself. Ask the robot vendors for help. Ask the system integrators for help. We spend a lot of time with our customers prior to them even buying a robot doing planning, helping them with layout of work cells, doing cycle time estimates, helping people even with tooling ideas. We don't build tools for people, but we definitely help them on tooling issues and so on. And bottom line is the proper resources will absolutely make or break your project. So last poll we're going to jump into. All right, so do you have the manpower to automate? That's the question. Are you going to be able to do it? And if you do, are you going to be able to do it in-house? If you don't, then are you going to be needing a systems integrator? So it's, do you have the manpower to automate in-house, or do you need a system integrator? And there's three choices. I have no manpower in-house to automate. I have some manpower to do this in-house and need some SI assistance, or I'm a system integrator. So it's really, are you going to do it internally? Are you going to do it in-house? Or I'm sorry, are you going to do it internally? Do you need a system integrator? Or you are a system integrator and you're in here listening to all of this, just maybe trying to pick up a couple of things that you probably knew but maybe forgot. So we'll let this go for a second. Like I said, the number one is you're going to do it in-house. I'm sorry, you have no manpower to do it in-house. Number two is you got some manpower and you're going to need some SI assistance. And number three is I am a system integrator. Okay, so I'm going to give them a couple more seconds. We're still getting a few more people filling this out. Thank you very much. It kind of helps everybody see what the balance is here. Just a second so we can get through this. All right, whoops. There we go. So here's the numbers. We came out again, almost even. So on the one side was I have no manpower in-house to automate, about 35%. I've got some manpower, and we're going to do some SI assistance probably as well, which is 35%, and then I am a system integrator, it's about 30%. So they're kind of balanced out. So just want to share that with all you guys. All right, let's hit our summary. We're just about done here. So what we focused on were these 5 areas of preparation. It's not everything you need to think about before you do a robotic application, but it gives you an idea so that you can start thinking about the things that you're going to want to share with a robot vendor. We strongly recommend, even if you weren't going to use Epson, even if you weren't going to use some other robot vendor, the robot vendors are here to help you guys in understanding how to attack your application. We're happy to help you in that regard. So these 5 areas, again, you want to clearly define why. Why do you want to do automation, and make sure you get alignment in your entire organization, especially up at the top. Make sure the top folks are always all in alignment on, yes, the reason we want to automate is cost reduction. The reason, how did that happen? The reason that we want to do this is because of cost, or the reason we want to do this is because of quality, or whatever that might be, but make sure that we are organizationally aligned. Then next is defining your process, and make sure you document it. If you come away with one thing out of this webinar, if there's only one thing, my suggestion would be, if you haven't documented your process, be sure to go back and get a team together to do that, of how you do things today. That will help you both in automation and in having a kind of a security blanket just in case something happens to those experts at your facility. Identifying your requirements. What do you really need? I need this type of cycle time, or I need this type of precision. You want to understand that before you go out and reach out to the robot vendors. Now, I say that at the same time, we can help you in understanding what that is to make sure that we're helping you choose the right robots and automation solutions. Automation components. There's a whole bunch of different things that you want to think about related to that. Are you going to need vision? What method are you going to use for part presentation in terms of feeders? You're going to need to use bowl feeders, or you're going to need to use flexible feeders. And there's all other presentations on the details of all that, but all these components you need to think about. And then finally, manpower. So are you going to use a system integrator, or are you going to need to do things in-house? Either way, we always suggest to have some experts available to help give you some guidance so that you make sure that you're able to do things in the best way. So, here at the end, I want to say thank you so much for spending the time with us. Come visit us at the Battery Show. The whole reason we were doing this presentation was to kind of give you a taste. We're going to have a couple of demos there at the Battery Show in booth 1110, and that's coming up here real soon in September. Hopefully all of you are going and attending that show. And we're going to have a couple demos that are going to show off force guidance and also show off vision, I believe, and some of our newer products. So that's going to be really exciting. And if you did want and need more information from Epson Robots, there's some contacts there at the bottom. And what I'm going to do is turn this back over to Chris for questions.
All right. Well, thank you, Rick, for a great presentation. We're now going to move on to the question and answer portion of our event. As a reminder, to participate in our Q&A session, just type your question into the text box located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen. And please note that we're going to try to get to as many questions as we can in the time that we have left. If we don't get to your question today, someone will get back to you after the program is over. So let's go ahead and get started with our first question. Rick, we got a couple of questions coming in here. First one is, do you have experience in the food industry, and can someone call me?
Yes, we do have experience in the food industry. It's interesting, I mentioned a little while ago, we've had customers come to us to do cake decorating, which is a kind of a spin-off almost. It is the food industry. But we've also done a lot of things where customers have asked us for sorting foods, for setting up foods before they go into ovens. Not so much on the process side, but more on the food handling side. So when I say the process side, I mean like mixing and doing all that type of thing, no. But yes, we do have a lot of different experience on the food side, and happy to speak to someone. There's a lot of different applications in the food area, so it's hard for me to say that, yes, we definitely have done this person's application, but we're happy to talk to them about it and see what they're looking for and see how we can help. Packaging is a big area in the food industry where we help out.
All right. Well, thank you, Rick. We'll move on to our next question for you. How long does a robot typically last?
Wow. I love that question, and it also scares me. And here's why I say it that way. I love the question because We have robots that are in the field from Epson that have been out there for 15 and even 20 years, and we'll get customers calling us with questions of wanting to redeploy after they've been running for 15 years and so on. And the reason that scares me is because if they're 15 or 20 years old, they're probably running at half the speed of what robots today are running, and so we'd really love them to have the better technology, the newer stuff. But typically what you'll see is the robots, and it really depends on the robot and the vendor. Typically you'll see people use robots, they'll reuse the robots, and they'll get a good 7 or 10 years of life out of them. We do, like I said, we get more than that a lot of times on our robots, but in general, you're looking to reuse them. That's the whole reason you're using robots, and so usually we'll see people use them for 2 or 3 years, then change the application over to something else, use them for 2 or 3 years again, and then a third time, and that's usually typically what we'll see.
All right, well, thank you, Rick. Another question here for you says, how long does it take to put together a system to get it up and running?
Oh, that's a really good question. There are applications out there that we've had customers that take less than a few weeks. And these are people that are experienced, and it's generally a very simple application. Remember I keep mentioning our T3, Synthesis T3 all-in-one. That robot is made for very quick, simple applications. It's just a simple pick and place. Experienced people can put things together with that in days. Even inexperienced people can learn and use it and get it working within weeks for their application. But that's not typical. The typical applications with our robots and so on generally will take more months, and so you're usually talking about maybe 3 months to 6 months for a typical application from start to finish and putting those together. There are some applications that take longer than that, but those are usually where it's a giant line and there's a whole bunch of different processes that are being done.
All right, thank you, Rick. Just a reminder to our audience, again, to ask a question, just go ahead and type your question into the Q&A text area located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen and submit your questions. We'll try to get to as many as we can in the time that we have left. Again, if we can't get to your question today, someone will get back to you after the program is over. Our next question for you, Rick, what are the advantages of using a SCARA over, say, a collaborative robot?
Oh, that's a really good question, too. Those are some good questions today. So collaborative robots generally have one significant limitation, which is speed. They're not able to run at full speed because we need them to be safe so that in case a human comes up or is working with the robot and is within that work envelope, that the robot is able to stop quickly enough and softly enough so that it doesn't hurt the human. In the case of SCARA robots, they're built for speed, so their whole purpose is all about high-speed applications. Now, SCARA robots typically are put inside of an enclosure, so if a human opens the enclosure up, or if the human comes close to the robot's going to then move down to a much slower speed. So the SCARA robots run far faster, and that's a huge difference. Also, generally, the SCARA robots will have a much higher precision capability than what the collaborative robots will have. So for high-speed, high-precision applications, the SCARA robots are better choices. But for very simplistic applications, a lot of times material handling, those types of things, low volumes, the collaborative robots are an excellent choice. So it really depends on the application which way you would go, but the generic statement is speed and precision goes down the SCARA way. If it's really simple and there's going to be a lot of human interaction, then you go down the collaborative way.
All right. Thank you, Rick. Looking at another question here for you, it says, how do I find a system integrator that is familiar with my application?
Yeah, that's a good question, too. The way we have a series of different system integrators that we work with quite a bit. And so we generally will have people come to us with their application. So the end user would come to us, we'll have a discussion about their application, and then we'll talk with them on how they want to proceed. Do they want a system integrator that's really close to them? Do they want a system integrator that has tremendous experience with something similar to their particular application? And then we'll help suggest some different system integrators to possibly speak with for their particular application. So in a nutshell, we have a giant list of a lot of different folks that we work with that we typically will refer them to, and then we'll work all the way through. We won't just hand them off to the system integrator. We will work with them all the way through to the completion of their application.
All right, and looks like we have just one more question for you. What is the operational humidity window your robots are able to handle, and are there variations of humidity levels when they are operating with regards to different models that you offer?
That's one of those that off the top of my head, I don't know the actual number. I do know that there is a standard number that we have that generally works across the board for all of our different robots. And it's, I just can't remember. I want to say 20%, but I hate to say that and be wrong, even though I just threw that out there. Stacy is looking something up real quick, but I don't know if it has it on that particular spec sheet. So off the top of my head, I'm sorry I don't have that. If we give us 2 seconds, she might be able to open up a spec sheet real quick. Just open a G-Series. That's okay. That's one I probably will have to we'll have to do offline. But the one thing I will say about that is that, yeah, it's not really different related to this model or that model. It's pretty much the same across the board for our different models. But there is kind of a range that we generally will ask people to make sure that they follow as far as the humidity level.
All right, Rick. Well, fantastic job on the Q&A. That is all the questions that we have for today and all the time that we have for today. I'd like to thank Rick. The Battery Show appreciates your time and expertise on today's topic. And I'd also like to thank our sponsor, Epson America, as well as everyone in the audience. We appreciate your attention and participation. Once again, if we didn't get a chance to answer your question, we will get back to you after the program is over. And within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been available to listen to today's event. This webinar is copyright 2018 by UBM. The presentation materials are owned by or copyright by The Battery Show and by Epson America Incorporated, and the individual speaker is solely responsible for his content and opinions. On behalf of our guests, we'd like to thank you for joining us, and we hope you have a great day.